Welcome to this new tutorial where we will create our own token for Solana network using the new Metaplex standard. Today we will be using the Quicknode Guide on how to create SPL fungible tokens using the new Metaplex standard, explaining the process using plain JavaScript with Node. Let's create a folder that we will open in Visual Studio Code and open a terminal where we will run the command npm init. We will use the default values by continuously pressing enter. And then we will see that our package.json file has been created. Here we will add the following line to use module import. And we will import the following libraries: Solana with tree, Metaplex Foundation, Metaplex token metadata, Solana SPL token, and FS. We will create our Quicknode RPC to ensure a fast and reliable connection to the Solana network. If you don't have an account on quicknode.com, you can create one with your information. After verifying your email, you will be ready to create your RPC. Select the Solana network. Choose DevNet and our basic plan, which allows you to create one free node. Now we have our RPC created, which we will be using shortly. Let's programmatically create a wallet as follows. Create a new file called wallet.js. Import the following functions from the Solana Web3 library and import our FS library. Create a variable named endpoint, where we will paste the RPC of Quicknode that we just created, enclosed in quotes. Create a new connection using the connection function and our RPC. Generate a new public-private key pair and log our public address on the screen. We will use this address shortly. Now, create a variable named secret array that will hold our secret key from the generated pair. Convert it to a string with values separated by commas. Convert each value to a number type using this function. Convert this variable to a JSON string and save it in a file named guys.secret.json. We will need this file when creating our token. Execute node wallet.js. We can see that the guy's secret file has been created. For now, we need to fund this wallet with Solana for testing. Take the public key that we just logged on the screen and request an airdrop on SolFaucet.com. Now, let's start with the code to create our mint.r token. We will create a file called mint.js, and now we begin importing all the functions that we will be using from each installed library. Remember, you can directly copy this code from the Quicknode Guide on how to create SPL token, which we provide in the description, making any necessary modification based on the code present in this tutorial. We will also provide a link to GitHub repository for this code. Import our wallet that we created in the previous step in the following way. Starting here, let's create our constants. Begin by declaring the endpoint with our Quicknode RPC, exactly as we did in the wallet.js file. Create a new connection to the Solana network as we did before. We will define our key pair using our private key obtained from the guy's secret file as follows. Create our Metaplex objects, which receive our connection to the Solana network, and configure it to use our user wallet to sign transaction and use the bundle storage service with the options shown on the screen. Create the constant mint_config, which will include the number of decimal for our token and the number of token to mint. Now, let's create the metadata for our token. In this constant, my token metadata, we will provide a name, a symbol, and a description. For the image, we will use a URL. In our case, we will use the URL of our collection PNG that we uploaded in the video on creating a collection using Candy Machine v3. You can find the link in the description. We need to create a second metadata object called on-chain metadata. We will include it in the mint transaction, and it will contain the name and symbol we have set, a URL obtained when uploading the original metadata, and the parameters, creators, collection, and uses, all set to null. Let's create an asynchronous function called createNewMintTransaction that will receive the collection on the blockchain. The sign-in private key, a new account that will be the address or identity of our token, the token where the created tokens will be deposited, the account that will have the authority to mint new tokens, and finally, the account that can freeze and unfreeze tokens. Create the constant required balance to determine the minimum balance required to create a new token and avoid rental costs on the network. Create the constant metadata PTA, which will be the address where the metadata of our token will be stored. Let's obtain the address that associates our new token with the account where the tokens will be deposited and save it in the constant token ATA. Now, we will start creating our transaction, which will contain 5 different instructions. The first instruction creates a new mint account and takes the following parameters: the public key of the payer for the transaction, the public key of the new account, the space reserved for the account, a constant taken from the Solana SPL token library, the required balance obtained from the network to avoid rental costs, and the owner address of the new account, which is the address of the SPL token program taken from the Solana SPL token library. The second instruction initializes the new account and requires the address, the number of the decimal for the token already established, the minting and freezing authorities, and the owner address of the new account. With the third instruction, we create a new account associated with the destination address of the token. It receives the account paying for the transaction, the destination account of the tokens, the account owning the tokens, and the mint address. The next instruction specifically defines the tokens to be minted, taking the token identity or address, the destination address where they will be deposited, the minting authority, and the quantity of tokens. The last instruction associates our metadata with the minting. This function receives 2 objects as a parameter. The first object includes the configuration and contains the address where the metadata will be stored, the token identity, the minting authority, the wallet paying for the transaction, and the wallet authorized to update the metadata. The second object contains the metadata itself, the isMutable property set to true, and the collection details parameter set to null. Our function will now return this newly created transaction. We will also create a function to upload the metadata. It receives the metadata and sends it through the metaplex object. It prints the address where it has been uploaded on the screen and returns this address. Next, we need to create our main function. Let's start logging the steps on the screen, starting with the first one, which is uploading the metadata. We have decided to request the balance of the account that will pay for the transaction and log it on the screen to confirm that we have sufficient funds for the operation. We call the upload metadata function with our metadata. And then we update our on-chain metadata object to set the received URL in the URI parameter. We print that the second step is being executed. Here, we will generate a new pair of public-private keys that will serve as our token address or identity. We log this information on the screen and call our createNewMintTransaction function with the collection, the wallet we created in the previous step, the address of the token we just created, and the public key of our wallet, which will serve as the destination account where the minted tokens will be deposited, the minting authority, and the authority for freezing. Once our transaction is created, we move to the final step, which is executing the transaction. To do this, we obtain the hash and height of the last block on the network. The height refers to the number of blocks preceding it. We update our transaction with these parameters and add the payer parameter with our wallet that will pay for the transaction. Now we send the transaction using our connection, the transaction we created and configured, and the private key that will pay for the process. We save the result in the constant transaction ID and log all the information on the screen. Add a call to the main function and execute our code with Node Mint.js. We can see how all steps are executed, and we have achieved a successful result. We go to the minting address in the Solana Explorer and see our token with its image, name, quantity, etc. We hope this information has been very helpful for you. Remember to follow us on all our social media channels and do not hesitate to contact